How to create and add complex number in Java. Complex number is a simple mathematical term. I hope you all are aware of this. In this complex number, there are two types of part. One is the real part and another is the imaginary part. The imaginary part is denoted with the I. Let us take on an example. Suppose the complex number is 3 plus 2i. In this case, the real part will be the 3 and the imaginary part will be 2. Why it is 2? Because the I is associated with 2. That is the reason it is known as the complex number. In Java, if you want to work with the complex number, there is no built-in type present to support you. In that case, you have to use the custom method or constructor. We can also use the simple approach like you are designing one function where you are sending the parameters of the complex numbers. You have taken complex numbers from the user and then it is sending to the function. That is the simple approach, but here to make it more simple and user friendly, we are using the constructor concept, which will also give you some insights of object oriented programming. But let us check the mathematical formula of complex number addition. Though with the complex number we can do the subtraction, multiplication, division, etc. But in this particular case, our focus will be on to the addition, right? So let's check the formula. Let me bring the marker. Suppose there are two complex numbers. One is the 2 plus 3i. Let me write 2 plus 3i, and another is the 3 plus 2i. The formula says that the real part 2 plus 3, this is the real part, will be added, and the imaginary part 3 plus 2i will be added. Separately these two things will be added, right? So the 2 plus 3 will be added and this will bring the real number 5, right? And this 3i plus 2i will bring the imaginary number 5i. So the new complex number will be the 5 plus 5i. So this is the complete formula. We have to implement the same thing in our program. See, here is the first complex number a plus bi, second complex number c plus di. Here a plus c and b plus d. We are performing this. You have to remember this formula. Let us move ahead for the functions in the program. Here the first one will be the constructor class. The constructor class is nothing but a simple operation that will create single object for a complex number. There we will take two part, one is the real part and another is the imaginary part for the real values and imaginary values. The second one will be the function add. In this function we will add two complex numbers, right? We will add two complex numbers. And the last one will be the main function. In this main function we will provide values to create complex numbers by calling the constructor. Later we will call the function add. This will become all clear when we go for the detailed discussion. So let us move ahead. Now let us check the constructor class. What is the constructor and how we are doing the construction in the complex number. First, we have taken two global variables. This is the integer variable, right? This is the integer variable. One is the real and another is the imaginary. Now let us have a look at this line. This line is the constructor. Through this line we are creating the constructor. Why we have given the name main? Because our Java program has saved with the name main, sorry for the handwriting, main.java, right? And as our class saved with the main.java name, the construction should have the same class name. Whatever the class name is used to save the program, the constructor will have the same class name. So this line is what stating that a object will be created. Suppose it is an object. An object will be created. The object has the capability to take two items. One is real integer value and another is imaginary integer value. So in the object we can insert a real value and an imaginary value, right? This line states this thing. Object will be created and it has two spaces for a real value and an imaginary value. Now what this line is stating, here we are using the this keyword. The this keyword is do what? The real value that the user is providing will be inserted into the object using the this. The real value which is given by the user will be inserted into the object, right? The same thing will happen for the imaginary. This line will help to this line will help to insert the imaginary value into the object. So basically what the constructor is doing, the real value the user, whatever the real value and imaginary value provides the user, will be inserted into an object, and the real value and imaginary value will be stored there. In this way a single object, a single group will be created that will serve as the complex number. I hope this clear to you. Let us move ahead. This will make clear to you more. We will check the main function first before moving to the add function. Let's see what this line is talking about. This line is talking about to create an object n1. Suppose this is an object is created. With this line, this complete operation is done. An n1 object will be created. Now in that n1 object, the 7 will be the real number. This goes there, and the 2 will be the imaginary number. So one complex number has created. This is the 7 plus 2i with the n1. Alright. Now n2. n2 is another object which will have the 6 and 3 values. The n2 will be created. This is the object n2. Okay. This is the object n2. In the n2 object, the 6 and 3 will come, and the complex number will become 6 and 3i. This is the way we are creating. Now you might ask why the 7 is the real one, why not the 2 is the real? Because we have mentioned here the first one will be the real. Check here, the first one will be the real one. That is why whenever we will give the first one, it will be noted as the real one. Whatever the value we will give at the first, it will be noted as the real one. So in this way we have the first complex number and second complex number. In this section we are printing the complex number, but not usually we are printing with the constructor. See, here we are using the dot real. Whenever we will use the dot real dot imaginary, we will use the constructor or object, the n1. This is the n1. This is the n1. This is the n1, and in the n1 there is the 7 is the real value and 2 is the imaginary value. Now the n plus n1 dot real will denote the 7 value, and the n1 imaginary will denote the 2 value. As we are extracting the values from the object inside of the object, that's why we have to use the dot. As we are extracting the real value from the n1 object we have to use the dot. The same thing will be done for the n2 as well. So this section will check is the constructor that we have declared above is working properly. That means we have created the n1 and n2 complex numbers properly or not. I hope this becomes this clear to you. Okay, so now let us move ahead. Now in this section we can see that the add function is being called. In the add function, the n1 n2 is shared. The n1 n2 are the complete object, n1 object with the n1 object with the 7 value and 2 value. This complete object will be shared to the through the n1. Alright, let us check the add function. In the add function, the simple a temporary object of complex number will be created. A temporary object temp is being created with the initial value zeros. That means a object, this is the object, will be created with 0 and 0. This is the temp. This is the temp. This object has been created. Now let's check. In this section we will implement the formula. The n1.real and n2.real will be added. What is the n1.real and n2.real? The object n1 and object n2, whatever real values have, we are extracting the values. Whatever the real values have in the n1 and n2 will be extracted and added. This addition value will be transferred to here. This addition value will be transferred to the real section of the temporary. The same thing will happen for the imaginary as well. The n1 imaginary and n2 imaginary will be added, and in the place of the temporary imaginary, this is the temporary object, and here it is the space for the real and it is the space for the imaginary. In this section the imaginary part will be added, and in this section the real part will be added. In this way a completely new added complex number will appear. So let us check, and here we are printing the newly added complex number. Now whatever we have discussed, you should understand this. Now it is time to implement or execute the program. Here we have taken one online Java compiler, but if you want you can take a local Java compiler like Eclipse. Here you can see this is the constructor, this is the main function, and this is the add function. Whatever we have discussed till now, all the code snippets are merged here, and now it is time to execute it. See, the execution is completed. Through this execution we are getting the two complex numbers, 7 plus 2i and 6 plus 3i. See, in the main function we have given the number configuration as 7 2 and 6 3. As the first one will be treated as the real, the 7 will be treated as the real, and the second one will be treated as the imaginary. So as the output is coming properly, we can see that the constructor is working also properly. Now adding two complex numbers, if you check, 7 plus 6 will give you 13 and 2 plus 3 will give you 5. So this is also coming true. So in the end we can say this program is working completely fine. Now we have given you this you can treat as the draft. Now with this draft you can do your experiment as well. We have shown you the process to add the complex numbers. You can also do subtraction of complex numbers. In that case your formula will be different. Instead of this plus, let me bring the marker. Instead of the plus, there will be the minus. So you can treat this as one homework or assignment and try to implement your own subtraction program and see what output is coming. So I hope you have enjoyed this video. Stay tuned and goodbye.